Welcome to everybody who's connected at the moment, and I would like to explain you just a couple of rules we would like to enforce. So Sabrina, if you can go to the next slide. Okay. So basically, all the attendees obviously are muted, so that only the speaker who is going to make the speech has got the possibility to talk, and we will be monitoring the situation. So all the questions you have should be posted in the question and answer panel. This way, everybody can see the panelists, and we have a moderator who selects the best questions to the speakers. We allow 1-2 questions after each speech, and then at the end of the session there's a 15-minute discussion session where you can make your questions, and as I said before, the best ones will be selected. Then the most relevant question, okay? And we enforce the chairs to strictly keep the time, so we should not go over time. So when, let's say we're missing 3 minutes at the end of the presentation, the chair should advise the speaker to wrap up, because the presentation time is over. So it's very essential to keep the time, so we don't go over time. Okay? The agenda.
Oula,
yes?
I have a lot of interference. Some people are not muted, and it is difficult to hear you.
Oh, but okay. Let's see. Now everybody are muted, apart from me. Perfect. So this is the agenda. You can see it also on the web. So it's we have Martin Jones, Andreas GARCIA, Anne-Laure BECK, ARGANS, and then the second session of Aurélie, François SABATIER, Kevin BERGERON, and Dano ROELVINK presenting. So that's the agenda of today. We start with ARINO, Olivier ARINO, who will give a short presentation, and then Yves-Louis DESNOS will follow. So I say goodbye to everybody, have a good session, and we can start. Okay? Thank you very much.
Good morning, everybody. I'm Olivier ARINO. Can you hear me, Oula?
Yes, Olivier, we very well.
Perfect.
Okay. Thank you for joining this meeting very early this morning. I understand that yesterday we had 304 participants registered, which is quite a good attendance, meaning that the subject is interesting several persons in the world and players. Doesn't work. How do I pass my slide? Okay. So we had this webinar as a follow-up of 2 contracts that we initiated in 2019. We had the statement of work in 2018, and we awarded 2 large contracts to 2 different consortiums, and you will have the opportunity to listen to the final conclusion of these 2 contracts by the contractors themselves. One contract was awarded to ARGANS, and at the kickoff, the 3 April 2019, and closed its part the 20 January 2021. The other contract was awarded to to IC, and he started in February 2019 and closed 21 January 2021. So this is the repartition of the workshop registered participants. I hope that most of them will show up. We have, obviously, due to the subject, a large participation of the people involved in the different projects, meaning that Spain, England, France, Germany, Greece, and to a lesser extent Italy, are quite large participation. Why is that important? Why do people consider that important? Because, as you know, the sea level is increasing to global warming, and this is not. When you look at the IPCC projection, we are in the red curves, meaning that despite the speaking of the politician and also the trial from different groups in the world to reduce the emissions continue to increase. Therefore, the sea level is increasing, and it is expected to have, by the end of this century, 50 centimeters of sea level increase, and maybe more if we don't reduce the emission. Meaning that, as you know, if the mean sea level is increasing, of course, the impact on the coast will increase also, and the erosion will increase de facto. So, and when you know that without counting Canada, which is an associated member state, we have something like 50 to 60,000 kilometers of coast in Europe. This has a large impact of several ESA member states. Not all, of course, Switzerland, Austria are no coastal erosion, but most of the other member states suffer already from erosion. Meaning that the demonstrations that we are doing with that two projects may be followed by real application, a real impact on the coastline manager. So therefore, the scope of the project that we started was to see how we can use the novel observational capability of Sentinel-1, the constellation of Sentinel-1 and the constellation of Sentinel-2 in order to meet the requirement set up in a cardinal way. Basically, we wanted each of the consortium to analyze 1,000 kilometers of coast split into at least 3 member states over the past 25 years, meaning that we consider the 25 years because it is available archive of satellite data in America and in Europe. In Europe, mostly of STAR data coming from the ERS mission and Envisage mission, and with Landsat for the optical sensor. We had some quite sporadic acquisition of spot, but not covering all costs. So the phase 1 was a product specification, requirement engineering, and technical specification. The part 2 was a product validation, pilot service demonstration, and a possible rollout analysis. All of that will be presented by the two consortium. The kickoff meeting, I already say, we had a very nice midterm review in Bordeaux last year and in Nice for the ARGANS consortium in Bordeaux with IC consortium. And we had yesterday and the day before the two final presentation of the two consortium. I have to say that we granted to the two consortium access to a third-party mission for the same amount of money, and you will hear that Pléiades, but also several other very high resolution data were used in order to test some of the method and assumption. In a nutshell, France has been analyzed by IC, the coast of New Aquitaine, Normandy, and Alpes Côte d'Azur, Greece, Eastern Macedonia and Thrace, and Peloponnese, Germany, North Sea and Baltic Sea, Portugal, Northwest Coast, and Romania, the Romanian coast. This for the IC consortium. Then the ARGANS consortium has analyzed several sites in United Kingdom, and it will be much more. Dublin Bay, Cork Harbour, and several coasts of Ireland. A lot on Spain also, and the series on the cake was Canada, which is an associated member state of ESA, and something has been done in the Saint Laurent Bay. So I think that this is all for my introduction, and I pass the word to my boss, Yves-Louis, that will explain the Earth observation program and application area.
Okay, thank you, Olivier. Can you see the slide? Can you hear me?
Yes,
Yes,
we do.
perfect.
Okay, so thank you for giving me the opportunity to present the ESA activities. So I'm Yves-Louis DESNOS, I'm head of the data application division, and Olivier is part of the team as a senior advisor. So I'll try to cover in a quick time what we are doing in ESA in terms of mission, science and application. And also I speak a bit of some of the activity we had during the COVID period, which is unfortunately continuing. So the presentation is organized as first introduction to EO at ESA. Then I'll cover some results on land, cryosphere, ocean and atmosphere, some key results. We will see what we have done under this initiative for COVID and Earth observation, and I will finish by just a quick introduction of the program in which this study and this webinar is taking place, which is this EO Science for Society program. So just starting by our vision for Earth observation, at ESA is really taking the pulse of our planet. You see here all this planet corresponding to geophysical parameters which have been validated by the science team. So this is the end product we are delivering to society somehow. We have developed in the past a large number of missions. I was and Olivier working with Olivier at the time on the MVSAT mission, which is somewhere now hidden almost. I also worked on the ERS mission at the time, and we have gave birth to several lines of missions now. From this more general mission, multi-purpose, we have a line of science mission, which are science-driven. We are getting proposals from the scientific community, and they are selected through peer review. We have the Copernicus, well-known Copernicus program, which is really the workhorse of what we are doing for global monitoring and environment and security. And we are also building a series of meteorological satellites, which are then handed over to EUMETSAT for operation and exploitation. So in a nutshell, we have 15 satellites in operation, 40 under development, and another 13 under preparation. So let's, next slide if I can, yeah. So talking about the science mission, I just said they are science-driven, selected by a committee, funded through the envelope, what we call the envelope program. And we have an average one mission every 2 years. We have two categories, core and fast track mission. So in terms of the Explorer, you see the one which are either have been flying or are still flying, Gauches, Moss, Cryosat, Swarm, Aeolus, with their corresponding measurements. I don't have time to go through the details, but your community, I'm sure, knows some of them. In preparation of future mission, we have healthcare built with JAXA Biomass, which is an L-band SAR, Flex, Forum, and the Earth Explorer 10, for which we have 3 candidates, actually. So it's about science and innovation. We have, of course, a large scientific community, and they are producing a lot of scientific publications. These are missions with high risk, but also great rewards in terms of the scientific production. Just an illustration is the use of the first wind LiDAR in space and its impact on operational forecasting. And you see here the positive impact on the right side in red from the Aeolus winds assimilated at ECMWF. This is another view of what we can measure with this revolutionary mission from some recent results. And now we have also a new kind of mission, which are smaller missions, which are Scout. And the first one which has been selected recently is the ESP Max for monitoring process in the atmosphere using a constellation of CubeSats. So these are smaller, fast-track missions. Of course, talking about the Copernicus program, this is, of course, a new phase in Earth observation. It's led by the European Commission. It's an EU-ESA collaboration. And as I just said, it's managing the environment, mitigate the effect of climate change, civil security, and ensuring European independence. So in terms of the mission, you will see the product of those mission actually in action through this webinar. We have a SAR imaging mission with 2 Sentinel, one A and B already operating. So it's all-weather radar. I'm not going to dwell on it because I'm a SAR specialist, so I can spend quite some time introducing Sentinel-1. We have Sentinel-2, which is a multispectral imaging mission, high resolution, continuation of Landsat and Spot, but with 10 meter and different channels. So I think we would see really very a workhorse for some of the application we're undertaking. Sentinel-3 for ocean and global land monitoring, direct continuity of NVSAT. We have 2 units flying, 3A, 3B as well. We have just launched Sentinel-5P, which is a precursor in terms of measuring the atmosphere, and I'll show some examples of air quality as derived from Sentinel-5P. We are preparing for Sentinel-4, Sentinel-5, and we just launched Sentinel-6, which is now called Sentinel-6 Mike Frejus, and which is an altimetry reference mission. So Copernicus is really large. The data are full, free, and open. We have the number of registered users is enormous. We are producing 250 terabytes of data per day. We have 8 Copernicus Sentinel flying, and we are preparing now for its evolution. So just some picture of the Sentinel-6 Mike Frejus, which is the latest in the series of the Copernicus mission, which was just launched last November and already producing results. In terms of new mission, we are in phase A, B1 for a number of Copernicus new mission, which are CO2M, Crystal, Simmer, so polar ice and snow, sorry, for Crystal, Simmer passive microwave radiometer, LSTM for measuring temperature, CHIM for hyperspectral, and ROSE-L, which is an L-band SAR. So now going to the second phase of the presentation, talking about some of the results. These are just some of the imagery and exploitation of the Sentinel-3 mission. You see this giant iceberg which we have been following and which is now docked more or less near this island as measured with Sentinel-3. You have, of course, some more original application of Sentinel-2, which is used in this case for monitoring glacier and icefall in the Everest area. So this is just some of the, you see here the measurement of the ice flow velocity. Here we have just global view from space of the observation of all the glaciers in South America. So we can use the technology of this cryosat altimeter, which is a new generation SAR altimeter, combining the data, processing them in a different way, which is called SWAS processing. So you see the evolution between the normal processing and the improved processing. And from there, you can really, glacier by glacier, infer a time series and evolution of the glacier, which is giving you, of course, an early indication of the evolution of climate. So if I speak along the video, you'll see the overall results expressed of the glacier decrease and the contribution to sea level rise. Okay, so this is really 2% contribution to sea level rise, 20 gigaton of ice loss. Okay, here we are using Sentinel-1. We are not, this is ice velocity maps using Sentinel-1. We have several methodologies to do it. This is using, I think, tracking. We can really do this. It's not using interferometry, and you can measure at continent level the evolution of the ice shelf. So continuing, this is another example of what is being done on coastal on cryosat SWAS altimetry to measure the Tibetan plateau. We have seen also some results produced using Landsat time series and Sentinel-2, using different, of course, methodology for that. Now going for land quickly, these are some of the latest results we have done using Sentinel-2 and Sentinel-1 for crop mapping, so over Poland, and the corresponding classification which was done at country level. Another thing, kind of application is, of course, using Sentinel-1 interferometry. We can monitor at country level subsidence, and this is the map which is now generated using systematically this time series from Sentinel-1 and so-called method of persistent scatter interferometry. We have done agriculture monitoring at country level. This is a Spain example using Sentinel-1, Sentinel-2, and Landsat, and this is some of the production. Actually, it's used by the Sentinel for common agriculture policy monitoring, and I think some of the participants to the webinars are part of the consortium. We can also monitor fires. So this is an example of the synergy we have with the different missions, starting with the measurements of CO concentration by Sentinel-5P on the left, looking at the all-she measurement over the fire in the coast of the US, and then SLSTR on Sentinel-3 for the fire detection. We have also application for geohazard. This is an example of the consequence of an earthquake and tsunami, and looking at the city of Jakarta, and this is used by the local authorities and also by this is a project which was developed with the Asian Development Bank. We can also monitor deforestation. This is just the stepping from Landsat 5 in 89 to what's going on now with Sentinel-2 in 2019. Last but not least, this is a project which was developed by Olivier. We decided to pioneer a bit what we can do with Sentinel-2 at 10 meters. So this was the first HR land cover map at country level, which was used and which is publicly available using combination of Sentinel-2 and Sentinel-2B data set and the corresponding classification at 10 meters. Now I think we are doing the worldwide coverage with a similar resolution under the World Cover project. Atmosphere. With Sentinel-5P, we can measure the ozone hole. The ozone hole is somehow showing that we can have an effect with the protocol on some of the observation we are making from space, like ozone. So the Montreal Protocol actually had an influence on this event. And sorry for that. I think this crashed. So I have to restart the my computer crashed. Sorry. Just give me a second. So while I'm restarting, okay. So can you see again the screen?
Yes, perfect. Try to launch it again.
Okay. I was on the ozone hole, so I'm just trying to move forward.
Okay, yes, and the animation works.
I hope it doesn't crash a second time. So here I wanted also to share with you this observation. When we talk about air pollution, this is not even a national or regional, it's a global effect. There are long-range transport effect, and you can see this at a global level. So it's not, it's something we need really to take care of and take some measures. We are also capable today to measure really at ship level, more at ship traffic levels, the concentration of NO2 which we observe from space. And we have even the capability now to detect the things from single ship using specific algorithms. So this is work in progress, and this is of course being made available to the public. Regarding ocean, this is more or less sea level rise was already presented. I'm just presenting two things, which is the evolution of the sea surface temperature, where you can observe basically the major currents in the Atlantic Ocean and all the meanders, the complexity of what can be observed. And the second thing I wanted to show is really what we can do when we combine data from several sensors, which is what we call the virtual lab. So here the idea is for scientific purpose and of course research and validation, looking at combining the data from the various and products from the various sentinels. So you see some information on currents, you see the tracks from the altimeter, you see the SAR measurements, you see the SST measurements, and you can play with the data somehow and do science. So this is fully available today online for being used. So let me continue. I hope I can. So the thing I wanted just to show now is what we have done under this rapid action on COVID and EO. Is we were asked, can you do something with this observation? So we had early discussion with the European Commission, and we define and we say let's try to do it. So we worked in a startup mode, and we developed in less than 2 months the first dashboard with a simple objective, which was to provide the public information on the state of economy and society. We focused on the use of Copernicus Sentinel, and we use latest technology, which is platform AI. And of course, we try to derive parameters regarding climate, environment, economy, and agriculture. And so we were capable to deliver after 2 months just the first version of the dashboard. The numbers I'm giving to you today corresponding at the current development. So we have So this dashboard, something which is a single source of data and truth. It's made in Europe. It's straightforward by non-technical users. It's informative. It communicates the effect of the lockdown on all those parameters. And we have been capable to engage the public. So we have to date 164 economic indicators, 28 on agriculture, 244 on environment, and we have developed this with 32 companies in Europe. So we, you see here the link where to find the dashboard and some of the, of course, the time series. And here we can really look at the evolution through time over the last 2 years, including the climate reference to climate anomaly, looking at comparing the data to data. So you have the capability to interact with the data, and we have even some capability to do on-the-fly processing. So you select your area of interest, and you can choose your parameter and process it with the technology we have. So some of the really results which were made the headline in the press is some like the decrease of air pollution during the first lockdown was widely published. We attracted not only the standard press, but really a lot of public media interest through this dashboard. We also open a contest with engaging the public. So this is some of the proposal we received. We did it in 2 phases. First phase, which is getting the proposal, and second phase, trying to expand them at European level. And we have managed to expand 2 of the applications developed by our users. The first one is the flying airplane indicator using Sentinel-2, which we are doing now at European level, which has been validated, and which has been deployed wall-to-wall on all major airports in Europe. You see the evolution through time. The second one is regarding the truck traffic, so we can also observe them with Sentinel-2. And here we can really, you can select the area of interest and get them reprocessed for the period of time on your or the roads, major roads close to your location. So this is last but not least, we were requested in rush, can we do something on trucks monitoring at the border? And just to tell you, we are capable to deploy a solution in 8 hours, having really the capability to look back in time and show the various truck traffic. It's using, of course, the DataCube technology and AI, and just showing the power of the technology we have here. Last but not least, we are within this EO for Society program. I just really show what it does. In ESA, we have a so-called basic activity. Here we are in the context of what we call the trunk of the tree. This is a research and development program, and we are preparing for the grants, doing the grants in R&D for allowing the deployment of more operational or customized Earth observation. So this is quite fundamental. What we do in this program is exploiting leading edge European EO capability for the benefit of citizens. So we are extending the EO expertise in Europe. We are building on the ecosystem we have in Earth observation to address the needs of the society. We respond, of course, to the needs of the user, and this is at the core of this webinar and coastal erosion project, listening to the users, engaging them and working with them. And of course, we are working in close collaboration with member states, with the programs at national level, with EU and the UFC. And we are leveraging on latest technology. I had just a few words on what we have done in this rapid action on COVID-EO has been enabled by the availability of this platform, the AI technology and the DataCube as examples. So here we have, in terms of key components of the program, we have a science component, which is developed jointly with your ECRTD. The coastal erosion is within the element of resilient society, which is to bring EO solution for environmental threats. We are bang on. We are pioneering AI, artificial intelligence for Earth observation. We have an EO Africa program, about user engagement and uptake of EO solution for African news. We have some activities on civil security, as a regional initiative, also dealing with science application and platforms. And we have a system of open call. That means you can submit a proposal to ESA at any time and get funded for a one-year project, 150K. So this concludes my presentation. I wish you all a successful and good seminar, and I look forward to the recommendation you were stemming from this seminar. So have a good day. I have to join a meeting with one of our member states, so I have to leave you now. Thank you.
Thank you, Yves-Louis, very much.
So, the first I think it's Martin.
I'm just waiting for the I can share.
Okay, you go up for 1 hour.
So can you just confirm you can hear me and you can see my screen?
Yes, we do.
Yes.
That's brilliant. So welcome everybody and good morning. And looking at the 40 nations that are listening in, it's probably good afternoon for some and good night for perhaps some others that are listening in. Over the next hour, we're going to quickly introduce the Coastal Change Consortium and our version of the Coastal Erosion from Space project. I think it's been highlighted by Olivier at the beginning and also by Yves-Louis. Climate change is bringing a large amount of increasing storms. Those storms are more ferocious. They are happening more often. If we look globally, there's an awful lot more investment in coastal areas as populations grow and urbanization increases. This means that there is even more need for this sort of project as we move forward. So I'm going to quickly introduce who we are in our consortium. So our consortium is comprised of two separate groups. We have a service provider group, which is project managed by ourselves, ARGANS, an Anglo-French company. I'm based in Plymouth, and we're delivering the optical products and services, and we're supported by our Spanish friends, ISARSAT, who are delivering the radar products and services. Additionally, within our little group, we have our friends Advisio in the Luxembourg, who have an Earth observation data center. I think it changes daily, but at the moment it's about 30 petabytes big. But it does enable us to get instantaneous, at a click of a button, access to the full archive for the Sentinel-1, Sentinel-2 missions. And for this sort of project, looking back over the 25-year period, having links to Landsat, having links to MBSat, and having that immediate access to the Sentinel mission has been vital. And then supporting us in the validation and the use cases and the reason for the project, in some respects, are our user group. Now, we specifically looked at those institutions who sit right at the heart of government, who are the professional technical advisors to government. And therefore, in Spain, we are working with IHE Cantabria in Santander, who work very closely with METECO, the environmental department in Spain. We are working with the British Geological Survey, who work very closely with DEFRA, which is the British Environmental Department. We're working with the Geological Survey of Ireland, who in their own right are a public institution and work very closely with the Office of Public Works. And then in the province of Quebec, we are working with our partners Arctus, who work alongside the University of Quebec at Rimouski. One of the things we noticed when looking at this project is that there are quite a few definitions out there, but seldom are those definitions agreed by the whole community. So for our project, what we have declared is that we're going to use the term waterline when we're talking about that instantaneous snapshot in time, when the image is collected by the satellite, and therefore it's depicting exactly where the sea edge, land edge interface is at that moment in time. we're using the term shoreline to define where that particular land sea edge would be if it was related to a datum, such as highest astronomical tide or a mean high water spring, those hydrographic datums that we're all used to using. We then have a definition of a littoral line, because the shoreline is actually a calculation, it's a theoretical calculation, and therefore there will be times where that shoreline is predicted to be inland or where there is a fixed object, such as a cliff or a man-made structure, such as a seawall. Time series, I think that's fairly self-explanatory, but it's where we take a series of those other products and we look at what the effects and what analysis we can take from looking at several of those individual products. And then, of course, out at sea, the depth of closure is that depth below which, although there is effects from the winds and the storms in the sea, the effects on erosions is considered to be not significant. So very quickly now, just before I hand over to Anne-Laure, who's going to take us through the products, and then she will hand over to Andres from BGS, who will take us through the workshops and the validation. I just wanted to give some highlights. So as you heard from Olivier, we were asked to provide 1,000 kilometers of coastline. Actually, within this project, we ended up looking at over 2,000 kilometers of coastline, which is about 4% of the ESA membership's coastline. And we did go back for the full 25 years, thanks to the access to Landsat, Envisat, and ERS that we've heard of before. Again, we've both looked at optical sensors, multispectral imagery sensors, as well as the radar sensors. And I think it's also fair to say that we were extremely grateful for ESA for allowing us access to the third-party mission. That allowed us access to some very high-resolution commercial imagery, and that for us was vital in our co-registration process. As we're all aware, we want to actually observe from space the real changes, and those real changes need to be within the confines of not being the error of the sensor. So co-registering the imagery and using the very high resolution imagery allowed us to get a real positional accuracy for the pixels at 3 meters on the ground. We chose 4 countries to work with, and you've heard who they are, but I'll go through them again. So Spain, United Kingdom, Ireland, and in Canada, the province of Quebec. And we looked at over 16 sites. The reason that we looked at those over 16 sites wasn't to choose a site that's the same in every country. We looked at the varieties of different geomorphologies around. So we wanted to really push what one could do with Earth observation. But I think the message that comes out from that is that using these techniques, it's a truly globally scalable capability. So for all those nations that are listening in that haven't been part of the IC or part of the ARGANS contribution to this subject, this is something that can be moved to anywhere in the world. We held 4 workshops, and they proved to be exceptionally successful, with over 600 people listening into those workshops, ranging from academics and institutions to local government and national government. We delivered a pilot demonstration tool of a data access portal, which enables us to use HTTPS web services capability to find the data that we have, and we've published peer-reviewed papers. So I'm now going to hand over to Anne-Laure, and she's going to take you through the processes and the products.
Thank you, Martin. Thank you. I will share my screen to present you the different processes and products before Andres show you how we validate these. Perfect. So our different processor and products. So as Martin just introduced it, the first processor is the geolocation one, because a perfect overlap between all our images through time, because we're working with a time series perspective to cover those 25 years, is really, really important to be sure that we are looking at real change and not just shifts in the image. So here's just an example of a correction that we have with just trying to get rid of this first panel here. Correction, so we have the example here when we have 1 point there that we are zooming here, And before and after the correction, we have a top shift around 10 meters, which is here because we are in Sentinel-2 image, pixel resolution, pixel size. And here a comparison between before and after co-registration. We are looking here at a similarity index score before and after the co-registration. And if before the co-registration, all our points and comparison points are around 0.5, 50%. After the co-registration, we are between 75 and 100% of similarity. So this image, this co-registered image, are then the inputs of our optical waterline processor, allowing us to extract very long line around all type of different coasts. So we are using optical images for this, and it's really the snapshots about the line reflecting the sea level at the time of the snapshot, allowing us then to capture different morphology around the coast, depending on the sea level. If sometimes we have some sandbars below water because we are high tide and so on. So we can capture the different morphology around the coast. These waterline are linked with a QC score. So here there's an internal QC, which is a line geometry quality control, and then we have a line positioning quality control. Can that quality control flag out the potential wrong line, for example, due to ice, like we have in the bottom left image, or sediment, like we have in the right image? These lines, because completing this optical waterline, we also have some SAR waterline. So the SAR processor is in three main steps. The first one is the calibration of the image and also applying the projection and geolocation according to the different orbit information and DEM. Then we extract actually the line corresponding with the transition between high backscatter, that would be the land, and low backscatter for the water. And finally, the SAR waterline also have a quality control with comparing with a different reference line, and then this reference line is used to try to calculate some rates, like we have here on the start day. We have a comparison with a reference line, and that allows us to calculate the different change through time. And when we are looking at long time series, we can see that we have a kind of a rotation of the start day, accretion and erosion, and this rotation is compared with the result we have with optical, and we can see that we have a similar behavior with our optical lines. So these lines, because they are just showing the state at the moment of the snapshot, have to be corrected to be actually able to be compared to another. So we move our waterline to a shoreline using different auxiliary data. So for example, tide gauge, data measurement, also beach slopes, to transform this waterline and shoreline. Unfortunately, because we don't have all the information around all the coasts, we have to interpolate most of our data to be sure that we have all the data we need. And that allows us to transform this instantaneous waterline into shoreline. So here we have the example of mean sea level. And here we have a nice example in Spain, where from one waterline we were able to extract a long range of different shoreline at different datum, and we can see how they place on the shore. And here all the example of the mean sea level shoreline we have for the year 2020. With all this shoreline, we can then build some time series analysis at different scale, because one waterline, one image, one waterline, and one shoreline. So we are able to have, for example, on the first image here, some seasonal change with a winter and summer rotation for the little pocket beach, and also some yearly analysis here between 2017 and 2019. And also some way more long-range information. So here, for example, we have this 24 years of analysis with the average erosion rate we found for this area. But to complete all this product, we need complementary information. So, for example, the seafront processor will allow us to capture the different area along the coast. So, for example, behind this red line here, this is where we can find civil works, cities, utility land with crops. And basically, this is an area where the shoreline should never be, except, for example, for a huge storm. Between these two, this red and green line, we have an intermediate area playing a kind of buffer role to protect the coast. For example, with deforestation, dunes, we can also find salt marshes, for example, and then the actual littoral with the tidal area here and where the shoreline should be. So to extract this different area, we can use a classification map because we can recognize these areas. And on top of that, classification area also provide very interesting information about the different context and environment along the coast and allow us to qualify the different erosion contexts that we can find. But the different environment around the coast is really and highly dynamic, and to really capture and improve our classification map and provide very accurate results, we need to perform temporal classification. And this temporal classification allows us to capture dynamic phenomenon. For example, here in yellow, we have the tidal area, which is below or above water, depending on our image. And with this classification, we can also capture some changes. For example, here we are North Wexford Bay in Ireland. In between 2017 and 2019, we have here an evolution of this sandbar, which was disconnected to the coast in 2017 and connected in 2019. And when we compare it with satellite observation, we can see that this disconnection here now it's attached to the coast. To complete this 2D product, we have also some 3D bathymophotera model, which is an estimation of the morphology using multispectral sensor. We want the morphology of the seabed. And we need to make a difference between the satellite-derived bathymetry, which is more depth retrieval information, and we are more into seabed morphology retrieval. And for that, we're using a physics-based model developed by Headley. So for our bathymophotera model production, we need to first have a good selection of the image. We need sediment and cloud-free, no glint, no ice if possible also. And then performing some atmospherical correction. So to be sure that we have the best parameters, we test different atmospherical correction, and the one provided by our processor is the best match for the in-situ measurement. And then we can provide this morphology map, this BMTM. Unfortunately, we realized that because in our area we have a lot of sediment, for example, some problems, we need to build some confidence map. So this confidence map will help us to know if we can have good confidence in the results, so green good, or not really, not good confidence, maybe because of too high sediment concentration. To build this map, we use the reflectance because we need positive real value, and then the concentration in color dissolved matter and suspended particle matter. And with this BMTMs, we can also build some time series analysis. Here it's the analysis of the position of the sandbar around the shore of Barcelona. And through the years, we can see that the shore is, the bar, sorry, is moving through time, and we also had some interesting results with a seasonal analysis. Thank you all for listening, and now after we present this wonderful product, Andres from the end user community will now present the validation of this. Thank you.
So, thank you, Anne-Laure. Let me share my screen with everybody 1 sec. I believe I'm good to go. Can you hear me and see the slides?
Perfect.
Yeah, you're good.
Thank you. So then, well, as I say, I'm speaking on behalf of a very large team. And my name is Andres Payo. I'm from the British Geological Survey. But as Martin has already described, we are actually 4 different nations, 2 geological surveys, a research institute, a government department, and Arctus, a company who develop satellite-derived product. And I have to make this point clear that we are all end users by ourselves. So we have our own requirements. But since the beginning of the project, we were fully aware that there are a much broader community of end users outside on each of the individual countries, and we reached to all of them since the beginning, and I will explain how we did that. But I have to admit that it's a challenge to summarize in 20 minutes everything that we have done regarding validation for a number of reasons. One is because we have 4 different types of products. We have 2 1D products, what we call the waterlines and the shorelines. We got the classification, the backshore classification, is a 2D model, and we got the 3D Basi topo terrain models. So those are already 4 products. And if you look at the number of sites that we have actually validate those results, it's a large, it's almost 2,000 kilometers. And we have a very long record of data. So it's a challenge. So to do the validation, but also to present everything in 20 minutes. So the approach that I'm following here is to give you a product-based kind of review. I'm going to be touching on individual products, but please keep in mind that the number of environments that we have including the analysis includes beach with microtidal, microtidal, sandy beach, gravel beach, cliff coast, non-cliff coast. So let's bear with me. So as was stated from the very beginning, this is a users need driven project. So we spend the whole phase 1 actually extracting what they are actually the requirements from the end users. We produce a full report, which is a technical report, 122 pages, which that's one that we call the user requirement document. It's available through the project website. And we also try to condense this very technical document into a more digestible kind of a short presentation at the International Coastal Management Conference with a paper. And as I said, there you will see also how we engage with the much broader community. So if you have to look for things that we have all in common, so we have one thing in common, that we all agree that to tackle the problem of coastal erosion, coastal flooding, we need to start looking at giving space for coastal processes and also looking at what's happening with the sediment balance, where the sediment, when you erode the sediment in one place, where the sediment is going to other places. But that's a general overarching kind of idea that all have, but you can imagine that we are all different countries, many different institutions, but we have country, site-specific, sometimes legal, and end-user type requirements. So we touch on every single independent detail on the independent nationwide workshops, and I believe you will have access to the slides, and there you have the link to the video recorded sessions that we have in each of the independent sessions, workshops. What I'm going to just show you is to whet your appetite, because we, the team, we are very proud of what we did for the workshops, and all the material is available. I'll say you will have access to the links, but I'll show you some of the lessons that we have learned. Those were mostly dissemination workshops where we tackle roughly the 3 questions that you see in the slide. So the first question was, what is feasible to observe from the space regarding coastal erosion using civil technology? The second question is, now that I know what is feasible, how confident am I on the changes that I see from the space that are actually real changes, or how many of them might be artifacts? That was the second question. And the third question is, well, now that we know what we can do, now that we know how confident are we on the data and the changes detected, how do we integrate this in our day-to-day and long-term management of the coast? All the different workshops roughly touches on these 3 questions, even though we have different structures to tackle those. And for example, in Spain, in the UK, that's the one I'm showing here, I can tell you that we, before and after each one of the sessions, before and after we ask and discuss the questions ourselves, we ask the public, and we have a large number of people watching the seminars for the session 1. That was the winner, the most technical one. We got almost 500 attendees watching that, and you see the numbers for the second and the third session. So when you ask the attendees before, how well do you think you can actually answer the question that we were tackling on each individual sessions? In session 1 is what is feasible. So you can see the response before and after, and you can see how they change, and you learn something by looking at how that changed. You can see that before, so many of them, they were somewhere able to answer the question or fairly well. There was a bit of a tight competition between these two, and there was an 11% on the extremely able to answer. When you ask the question after the workshop, then you realize that people you increase the number of people who can respond fairly well to the question. They learn something. That was a good thing. But also, and interesting, you can see that there is only 5% that are extremely able to answer the question. So I think that probably you realize how difficult it is to do this. Just going through the other workshops, again, really well attendance for the Ireland workshop. 450 people registered, 10 speakers, more than 5 EDIS key stakeholders invited and participating, and 10 local authorities. And even though those were designed to be national, kind of site-specific, country-specific workshops, we were actually pleased and impressed that we attracted people from, in the case of Ireland, more than 30 different countries. And as I say, you got all the material, all the videos are available online. The YouTube video has been watched more than 120 times after the workshop and keeps still increasing. For the Spain workshop, again, when you measure the impact that we might have on the people, you can use the numbers that you see on the screen. That is, they share the results of the workshop with the summary of the workshop. We share with all the participants, and right after that, you can see that the number of downloads of the paper that is related to the validation done in Spain increases, the number of downloads and reads increases, and again, the videos are fully available. You can watch. There was 2 sessions, the morning and the afternoon session, and they are available on Vimeo, so you can watch it and see all the detail. And finally, but not least, the one from Quebec, again, very well attended. That was a bit different in the sense that was 2 workshops, one similar to the first one and the second one where they did have focus group discussion. And one interesting thing that we learned from this one was that a lot of people actually didn't have previous experience, or not a lot of experience. You see the numbers. 45% of the people have less than 2 years experience working with satellite observation, and 40% none or little. So this is telling us something very important, that the problem is big. So people are looking for solutions because they have a problem and they are actively looking for solutions, and they see Earth observation as one of those solutions. But as I say, the YouTube videos are available. You will get a link at the end. So now let's move quickly to the validation. So the ultimate goal of the project, as we mentioned several times, was to analyze the full 25 years archive of data that we have. And here you have an example from Spain. It's a micro tidal environment, relatively clear waters, and we got a sandy beach backed by a urban area. And you see on the picture on your left, you see all the different lines that we got from 1994 to 2018, which combine Landsat and Sentinel shorelines. And then on the right, you see different transect, different profiles, and you see the trends that you can extract by when you look at how those lines have evolved over time. What we are doing, the end users, what we are doing is, okay, fine, we see this rate of change. When you compare this rate of change with other data, in this case, aerial photography, how those rates compared with. And in this case, you can see that the average erosion rate compared pretty well. From satellite is 4.79, from aerial photogrammetry is 4.68. So we were very pleased to see that. But this is a relatively, I would say, easy environment in the sense that it's micro-tidal, so you don't have to worry much about the tides. It's beach, so you don't have a cliff on the back, but that's not always the case. Something that I had to highlight from the very beginning is that it was clear to us that now we have something in our hands that we didn't have before, and it's the amount of waterlines, shorelines that we have now access, and we can analyze and came up with different ways of visualizing the changes has increased. And this is, for example, a heat map. Heat map, you can only approach those when you have a significant amount of data, and having a lot of temporal data for a large spatial scale is unique. And in this case, what I'm showing is that you can not only capture, as I showed before, the trend, the long-term trend, but you can also capture the response. When you have a change on the wave direction, you have the wave roses showing on the image. When you have a change on the wave direction, the sediment within those little embayments that you see on the screen rotates, move from north to south, as the arrows indicated. We were very impressed that you can also capture those using the shoreline products. But as I say, we are still, because we asked for a lot, we got a lot, and then we have a lot to validate. So we're still in the process of validating all the data that we have. That's a snapshot of, for example, the Republic of Ireland, a few places where we have the shorelines for an optical, and that's a long archive, as I say, from Sentinel Landsat missions. So what we are doing is a very detailed analysis. So we are comparing this with ground truth data, and one data that we are using, again, for the case of Republic of Ireland, we are using a vegetation time line series from 1995 to 2020, which is the interface between the vegetated line and the beach, which is free of vegetation. And we are comparing those with the highest astronomical tide, which is often used as a proxy, and getting the sense of how accurate those are. But we are also using, as my colleague Anne-Laure already showed, we also have the littoral line or the vegetation lines, where you can actually classify the backshore, extract the water line, and use it to do a comparison with a vegetation line database. Or, for example, you can also use it for challenging areas like this is the east coast of the UK, but it's a cliff coast. You can see you got the beach, then you got the cliff right close to the beach, and then you got a road that goes along the cliff that is suffering from erosion. So this is a problem. That's an erosion problem that we are trying to inform, but it's also a challenge when you are converting the water lines to shorelines, to a different datums. That can be a challenge, and in particular can be a challenge for the highest astronomical datum, the one that is close to the vegetation line, because as you project the auxiliary data to try to infer where the shoreline is, you might overshoot and go over the top of the cliff, like you see here. But then we now can access to the vegetation line to actually do a better quality assessment where we can trust or not those transformations. So that's something that we are also exploring. As I say, is to become with a number, a figure of erosion rate for the last 25 years, there is still a lot of visual interpretation. In particular, when you are looking at the old missions, the Landsat, you have to have a quick a visual check about what are you actually capturing when you delineate what you believe is the interface between the water and the land. And here you have an example where the boats are being picked up as the interface between water and land, when clearly it is not. So there is a lot of work to put a confident stamp on all the lines that you can see. And that's something that we are doing with the massive amount of data that we receive, and still doing that. So then we came up with innovative also approaches. How do you calculate the accuracy? And for us, for the whole team, we have been sort of dealing with the 3 levels of accuracy. The absolute, when you put a point into the map, a line into the map, how accurate is this location when you compare with other ground truth data? The relative is about when you measure distances between points, those distances that you measure on your product on the shoreline, for example, how compare with the distance you measure on the shoreline that you have on the ground truth data, and also geometric fidelity if you sort of keep the shape of the things when you extract those from the space. So in this case, it's an example from the UK where we identify what we call the non-foreshore points. The foreshore is the area that you can see between high tide and low tide, and when you don't have the foreshore, means that the waterline is roughly most of the time, regardless the tidal level, is most of the time in the same place. So we chose those points to calculate the absolute and relative accuracy. And here is an example for Sentinel-2 that you see the stats for this particular line, that the root mean square error is quite good. We were impressed for 19.7 meters. When you look at the relative accuracy, it's even better. That is around 14.2 meters for this line. So then the other challenge was, well, if you move to an area like Quebec, like Canada, where the cloud coverage is really heavy, can you still rely on optical to get a decent amount of water lines and the shore lines that you can use? The answer is actually yes. You see the numbers, the number of lines and kilometers that we were able to produce for Quebec, where we know there is a massive problem with cloud coverage. But then the question is, well, but if you've been lucky there, but what if you are not unlucky and you really have a problem with cloud coverage? So that's where the SAR came in, because it's transparent to the clouds. So then we knew, again, Starbase has been mentioned several times, but I will mention again here because it's a very well documented beach by our colleagues from Plymouth University. And again, you still have problems. In this case, it's similar to the picture I showed you earlier, that you've got a road very close to the beach and it's eroded. This is not a cliff, this is a barrier beach. And you see it's an embayment, and actually it's a multiple embayments. You've got a big one in the middle, but you've got small ones in the north, in the south. And they tend to rotate. The blue and the red color is a digital elevation, a digital map elevation difference, where the blue represents accretion, so you have a gaining on elevation, and red is a decretion, it's a decrease on elevation. And you can see that you've got blues in one area and red in the other. That's because the beach is rotating, it's moving the sediment from one place to the other. But when you zoom in, and I'm zooming now into the small rectangular square on the top of the embayment, which is the black pool sands, when you look at the volumetric changes, and remember that we said that we are very much interested in see where the volume is going. You realize that the sediment, the net sediment hasn't changed. You see that you've got roughly the amount of same sediment eroded and accreted. But interestingly, you can see that the yellow, the subaerial, is significant, which is good for us, because then you say, well, actually waterlines might be able to capture that. And that's what we were trying to do. Again, amazed by the amount of lines that you now get through SAR, because you are free, so you don't have the cloud problem with that. So you get a massive amount of water lines. And here you have one representation. How do you plot those? And this is trying to capture, again, in blue and red, erosion and accretion. You see the lines delineating the different embayments that we have. And you can roughly say that actually just capturing significant amount of change on this one. But it's difficult to interpret when you say, well, what if I use the mean values for, in this case, 2016 and 2017, and you compare those mean values? And then we were very pleased to see that, yes, you can see the rotation that we were expecting. We are now in the process to see if the numbers, or the rate of change that we see, how well this one compared with the number that we've seen from the ground. But that was a very good news for us. Then moving to the 3D model, 3D products. So we got the what we call the bathymorphoterrain model, and here is an example from Spain, from Barcelona, again a microtidal with relatively clear waters, and again positively impressed when you look at the scatter plot, the one you have on your left. You see a very good correlation between the ground truth depth and the one obtained from the satellite, and from 0 till about 5-6 meters, that was pretty good, I would say. And you can see there is a bit more scatter as you go deeper, between 6 and 10 or 12 meters. And the root mean square error, you see, pretty good, 0.89. And the plots in the middle with the color, with the clear blue and the dark blue, represents the areas where we have the absolute error when you compare the satellite with the bathymetry. So very pleased when you have clear waters, very pleased with the results. But even in the case of Spain, that you picture the beaches with clear waters, we also have a lot of plumes. And the metadata that has been produced in addition to the bathymetries is very useful for us, the users, to identify where we should be aware of if we see a change, or where we shouldn't worry because it's likely to be not a bathymetry change, is probably a plume, following the high, medium, and low quality criterion or confidence index that we have. I will just complete saying that we still have about a month and a half to go, so that's why we're still producing and validating a lot of the results. And every time you learn more about the products, you see the value of this one. And this is a quick example, but just reinforcing when sea level rises and you got a urban environment behind, that you have sea walls or flooding defenses like we have in the Wash in the east coast of England, the intertidal area sort of decreases, and having the ability to measure how this one has been changing in the last 25 years and sort of track if this is increasing or not because sea level rise, this is something very useful for all nations. As I say, this was a really flying through everything that we presented in much more detail on the workshop, so I do invite everyone to attend those in detail. I go back, I gave the word back to the Olivier. Thanks a lot.
Thank Andres. I see you still some time to run up to the end of your session. Do you
I am done, and I believe we have time for questions.
Exactly.
I noticed that there are a couple of questions that have come up during the presentation. So would it be useful if I kind of read one of them out? Both of them are quite technical and probably for Anne-Laure to answer. If you're happy, Olivier, I will just and then we can answer it so everybody can hear the answer. Is that okay?
Yes, please do so, Martin.
Okay, so one of the questions that has come in is to do, it talks about satellite-derived bathymetry, and I hope we will make the point that we've used the term bathymorpho-terrain model, and we use that for a very specific reason. But the question was, are we planning to convert the confidence maps and water quality associated with the final products to an uncertainty map, i.e. in meters? For the end user, that would be, I think that would be useful. So, Anne-Laure, would you like to just expand a little bit about the bathymorpho-terrain models, why we call them BMTMs, and the parts that we brought to bear with us?
Yeah, so we will say BMTMs because it's faster and easier to say. So for the BMTM and the uncertainty maps then, so we plan to do it in a quantitative way, so in meters to really assess the uncertainty around these BMTMs. For now, it's more a qualitative information that's how we can rely on our maps. But to convert this information in metrics and to have a quantitative is definitely something that we are working on.
I mean, I think I would add that from a company perspective, we have a long history in satellite-derived bathymetry. In fact, we're lucky that our two key seniors and our company hydrographer probably started the process about 20 or so years ago. So we were very familiar with satellite-derived bathymetry and how in lovely clear waters, the physics-based method is a fantastic thing. In the areas that we specifically chose as our sites for this project, we chose very complex geomorphological sites because that's what the user community are interested in, and that's where erosion takes place. So we were very clear. We didn't want to make the physics-based observations fit a known surface. We were looking to see whether there were very narrow surface changes over the periods of time that we were looking at. And we were particularly interested in that very inshore area. So trying to find an automated process that can pick out depths, image after image after image, meant that we weren't going to get a navigationally safe SDB type depth, but what we can see is various features, and then we have the ability to look at whether those features move over time. We've got one more question that has come in, and that's looking at our co-registration process. And it asks the question of how do we cope with using different instruments such as Landsat, Sentinel-2, the commercial imagery that we got through the third-party mission. It also talks about radar as well. So I'm going to again pass back to Anne-Laure and say, Anne-Laure, would you like to just expand a little bit more on our co-registration digitization processor? Thank you.
Yeah, no problem. So for the co-registration, so we are using different VHR, so very high resolution image, around 3 meters, and even sometimes if we had the opportunity below meters. And this VHR are co-registered on the different geodetic systems of the different country that we were working on the different sites, for the different sites. And then for those VHR acting then as master, we co-registered high resolution image linked with this VHR. For when I say link, is in terms of time scale. We're not going to co-register a Sentinel-2 from 2019 on a VHR for 2013 or something, because that would make no sense. So we're trying to connect those Sentinel-2 and Landsat image with the closest in time VHR. And we use just the VHR to co-register one Sentinel-2, the best one, the clearest, to be then the role and to have the master role to co-register all the other Landsat and Sentinel-2. And regarding the resolution idea, yes, we do use the smallest possible, the 10 meters for Landsat 8 and 15 for Landsat 5 to co-register properly all those different sensors. But we have to do several steps because we can't take all the stack of all our image and just try to co-register them all on the VHR. The difference in resolution make no sense to do that. So we have to do step by step using the Sentinel-2, which is 10 meters on the VHR, and then trying to do Sentinel-8 and Sentinel-2 and so on to don't have so many differences in the resolution and the spatial accuracy.
If I may add, Martin, we have not the chance, but the fact that Sentinel-2 co-registration in between the different satellites, but also in between the image, are within the specification, meaning that it's below the 10 meters. Therefore, once you get registered to one Sentinel-2 image, you can get the appropriate registration for that resolution, of course.
Of course. And I think one of the other things that is worth pointing out, I mean, I kind of mentioned it in the introduction, that it's a fantastic leap forward from Landsat to have the Sentinel-2 mission with its very, very precise bands and its 10-meter resolution. But for the changes that we expected to see, we knew we needed to have on-the-ground positional accuracy better than the 12 meters it provided, which is why we did the co-registration. The other thing is that commercial imagery comes with an incredible cost, and therefore we couldn't use commercial imagery throughout the whole process, and nor would we want to, because the signal-to-noise ratio in the multispectral imagery of Sentinel-2 is so wonderful. So using this mix of a little bit of third-party mission with the might, the power of the Sentinel-2 mission, I think has been a fantastic opportunity for us. I'm just quickly looking through to see if there's any more questions that have come in. And one of the questions says, are the applications open to use by the general or scientific communities, and can external project personnel apply the technology to his or her interest area? I'm going to answer that in a kind of slanted way. What we've said about the data, all the data products that we've made for the 16 sites can be made available, provided that the requester follows certain conditions. They need to go via one of our partners to make sure that they understand the risk associated, the validation criteria, and also that they shouldn't be using them for their own commercial gain, should be for scientific reasons. But on our website, after we've concluded the project and finished the final validation, we'll put out a registration form for people who wish to get access to the data itself. As far as the techniques are concerned, I think you'll all have to accept that where we have used open source techniques, we've made reference to that. Where it's been in-house bespoke techniques, we welcome you contacting us to see how we can work together as we move forward. And Olivier, I can't see any more questions coming up, but the questions are coming quite slow to my system. So if there are no more further questions, I'm going to... a question has come in. Did we co-register optical and SAR? So this
yeah, I just saw that question. So we're not co-registered optical and SAR together on the same system, but SAR image also have their own co-registration. Actually, the first step of the processes using DTMs and orbital information to recalibrate all the image together and to co-register the SAR image along together. But we haven't yet. This is now the plan because we had so many SAR and water lines and some time series analysis. Now the idea is actually to combine the two to see if we can complete our time series analysis.
So if another question pops up in the next 2 to 3 minutes, I'm going to hand back to Olivier and say that is a quick sample of what we've done from the Coastal Change Consortium. Please check out our website, which is coastalerosion.argans.co.uk, where the links to the workshops are also available. Andres has already mentioned the links to the workshops, which are also available via the partners' websites, British Geological Survey, IHE Cantabria, Arctus, and the Geological Survey of Ireland. If anybody has any personal questions, it's very easy to find ARGANS, and I noticed that Andres got his hand up, so I'm going to give the final word from us to Andres.
Thank you, Martin. No, because we have a few more minutes. We are, as being expressed from the beginning, we are now developing the roll-up of the project. So how do we go from looking at the archive to produce a service maybe in the future? And so if anybody listening to the workshops, they think they have a use case that we can use to make a good case that there is actually a need, an industry need or a government need to keep developing this further, please get in contact with either of your nations or directly to ARGANS, and we will use this to help us develop in the rollout program.
Excellent. Thank you very much, Andres, Anne-Laure, and Martin. Very clear message. We will break for coffee half an hour, and we meet in half an hour for the other presentation from the second consortium. If you have any other question, please do post that. My colleague Fabrizio will collect the data and will reply to the most important one at the end of the workshop at 12:30. Thank you very much and have a nice coffee. See you in half an hour.
Thank you. Thank you all.
Thank you all.
We reconvene at 11:30. Is okay, Ulla?
Yes.
We just go for a quick coffee.
Okay.
Okay.
I'll monitor with a new. Actually, can you make me host just in case somebody needs to be added as panelist for the next session?
Yes.
Thank you.
Okay. It's done, Ulla.
Okay, let me just check. I can still see you as host.
No, it's a pooling coordinator because you have now the possibility to promote attendees.
Okay. Because I see you as a host still, but
yeah. Unfortunately, maybe in this phase I cannot pass you the host role. It can be me passing you the role.
I'm just trying to see if I can, so I can make presenters this way. I can see Irene is presenter now.
Ulla?
See? Yes?
Olivier, yes.
Hello?
When you reintroduce the session, please acknowledge that the first consortium has been keeping the time quite well. And they do the same for the second one. Thank you very much.
Okay. Va bene. Okay.
Can we try the microphones of our guests? It seems that Kevin and François have joined us.
Yeah, the thing is that. Okay.
No, I'm here. I'm still here. I'll promote them.
Okay, and can I try maybe the microphone? François, Kevin, are you here?
Yes, they are being promoted earlier, Aurélie.
Mm-hmm.
I see them on the list of panelists. So if they can hear us, Kevin, do you hear us?
We don't hear you, Kevin, so far. We see you, but we don't hear you.
François, do you hear us?
You should unmute yourself, if possible, Kevin and François. Because now I can see them with the headphones, which is good.
Alors, est-ce que ça va marcher?
Oui, ça marche.
Ah, ça y est.
Eccolo.
Hello, hello.
Hello, Kevin.
I was a big problem with firewall and the support informatic resolved it. So it will be work very well now.
Now it works, yes. Sabrina, can you make Kevin a presenter so that?
Yes, it's done. It's
good,
done.
Good. Great. Yeah.
And what about François? François, can you say your word as well? To check if we hear you. You must unmute your microphone.
Io non ho toccato niente, il presente è François BERGERON.
Presenter is François at the moment.
Okay.
So if François can share his screen.
He doesn't have slides to present, but
right. But
he will talk, yes. He will share in mine, if mine.
Great.
So I'll pass the role to Kevin. Is it okay, Kevin? If you have a presentation to test.
I think you don't have slides neither.
Okay.
Either. Okay. They just need to talk. Okay.
They will
No problem.
My testimony only.
Okay. Okay. Well, then we can hear you loud and clear.
Okay, but for François,
Sabrina, can I meet Dano, please?
Fabrizio, are you in?
Scusami.
and Dano ROELVINK joined us.
Dano needs to be unmuted.
Yes, please.
I'll promote him. I'm just going to promote him.
Okay, and unmute him too so he can test the audio.
On m'entend bien, ça va?
We hear something, but we don't know who.
Fabrizio? I think.
Okay, now I'm unmuted. And I can start my video. Yes.
Oh, yes.
Hello.
Okay.
Okay. Maybe Dano is now presenter.
Yeah, he's.
Yes, if you please. Mm-hmm.
Mm-hmm. Okay. Olivier, did you want to say something? I can see your hand is raised.
Yes, I wanted to speak with Fabrizio
Okay.
to ask him to prepare a reply or a slide on the question of co-registration of Sentinel-2 data. Can he put on the discussion of the afternoon or for the
Closing
discussion the link to the validation report for the SE2 product that indicate the accuracy of the geolocation for SE2. May be useful for some of the users because we have several questions.
Okay, Fabrizio, did you get that?
Yes.
It's a public document, I think, so we can put the link so that the people understand well the geolocation accuracy of Sentinel-2.
Sorry, Olivier.
I wasn't.
Okay, no, I tell to put in the reply to the question about the register that the budget for the Sentinel-2 from the validation report.
Okay, I will try to find it.
If you find it again, put the link. It is available on the web so that the people can go directly here and see the accuracy of the geolocation of the Sentinel-2 image and understand that they are within the 10-meter accuracy.
Ola, it's Virginie again. Can we try to solve the connection with François and Dano, please?
Excuse me, Virginie. I see Dano, which is now presenter, and his mic is not muted. So if
I think it's okay.
Yeah. Okay.
Can you try to share your video?
Dano, I have integrated your slide and video in my presentation, so I will share the overall presentation. So it's fine. You have nothing to show. I will show it. But we still have an issue with François SABATIER that is not managing. There's some issue with his audio, it seems. François, maybe could you try to check the button audio and video on the top? Yes, and go to speaker microphone settings. And there you can switch from microphone or and see
yes, you can show the device.
Because I had the same issue this morning when connecting, and finally from another device for the microphone it was then working. François?
François, I'm trying to call you.
While we're waiting, François, if Dano wants to try out his presentation, he could. He's got the possibility.
Yeah.
To
Okay. Let's try that.
I have a small question. Can you also, when we restart, indicate that we'll put the presentation available on the site or not?
We put the presentations on the website. Yes.
Yes.
Okay.
I think it's. But I don't know if we need to contact your colleague, but it will be wise to have the set of presentation available and PDF, of course, for anybody that want to join.
Okay. We have the recording, but perhaps if Aurélie and Martin Jones authorizes me, I can make a PDF out of the PowerPoint and put that on the link to the agenda.
Yeah, it will be wise. Otherwise, the people will never find again. Okay.
We will sort that out later on today. Okay. Thank you. So Dano, finally.
Yeah.
If you go to the share possibility, it's on the center below on your screen, and go share content.
Yeah, I thought I was just going to use your presentation, but I can show it through mine. Okay, I'll do that. Wait a minute.
Okay.
Yeah, this is right. Your slides are already inside my presentation.
Ah, okay. Well then, sorry. Well.
But now I'm sharing, huh?
Yes, in fact, we can
so.
see your.
We can also.
We can see your desktop. Yeah.
This will probably also work. So then.
Okay. Yes, it works perfectly. Okay. But then.
Let's see. Yeah, this also works. Yeah, but.
The animation. Yes.
I have you. Do you see yourself or Ulla Waring? See this?
Yes.
You see this, huh? This
yeah.
is it in the way.
Yes, I can see a slight animation there, and I can see your mouse moving. Yes.
Yeah, but do you also see this little panel I'm seeing? Okay, now it's gone, I think. Yeah, okay. Okay.
Yeah.
That's it.
Perfect.
But we can also just continue on Aurélie, but then you have to, then Aurélie has to.
Well, if it's already incorporated in Aurélie's presentation, perhaps it's easier just to keep hers going and then give you you unmute yourself when it's your time to talk. I think that would be perhaps the best solution.
Yeah. Yeah, then I have a little bit less control, but okay, it doesn't matter.
But as you wish. For me, it's not a problem.
Let's see how it goes.
Yeah. So, or if you want to present directly from your laptop, then Aurélie.
I think this goes very easily, huh? So shall we just do that?
Yeah, it's fine. You can do by yourself if you want. Yeah.
Okay. Bene. So I think even for the next session we're all set. I remind to keep the time, so don't go over time, please, and we try to have the 15 minutes for the question and answer possibility. And so basically at 12:15 you should be done with your presentations. So we have that 15 minutes famous. Okay. And okay, and then 12:30. Okay, we start with the closure by ARINO. Good. So 15 minutes of a coffee break. If you want to get a coffee, now it's time to go get a coffee.
Okay.
Okay.
Bye.
Ulla.
See.
We'll see you in 5-10 minutes, okay?
Okay, va bene. I'm here.
Ciao.
Ciao.
Est-ce qu'il y a pour d'ailleurs, il y a des demandes ou pas? Bon, une fois que tu seras fait, on va faire relativement rapidement. Une fois que tu auras une idée, moi je voudrais écrire un roi pour leur dire. Il faut que je les Ok. Écoute, est-ce que tu reviens tout à l'heure pour la discussion? Bon, et en fait, pour la contrat, le truc, bon, je ne sais pas si tu peux le disposer, parce que je ne peux pas finir encore. C'était le projet. Et je pense que, comment elle s'appelle, Emma a envoyé le. Ou est en train d'envoyer le contrat. Ok.
Hello, Sabrina?
Yes, I'm here.
We have one or two colleagues from Normandy that would like to join the meeting, but they have not registered yesterday.
Okay.
Is it really too late, or maybe you can accept?
No. They can, if they register into the system, you will get the link, or you can pass the link.
Yes, she has done it. Julie Panis, she's in the system.
Okay.
But she has not received the link.
Okay, let me just check. Not done yet. What was her last name?
Panis, P-A-G-N-Y. Julie Panis.
Julie as with Julie.
Julie.
Ah, Pani, yes.
Yes.
I can see her as a participant too. It's funny.
Okay.
Okay, I send her the link
Super.
from email directly.
Okay. Nice.
Thank you. Okay. Okay, I can see her. Julie.
Nice.
She's in.
Super, merci.
We are back, Ulla.
Eccoci.
So it went smooth in the end.
Yeah, I think it's so far so good, as they say. There were also some nice questions, so that was nice. Let's hope also in the next session we get nice questions. Okay, so 7 minutes to go, and we start. Second only.
I mean, on the story of geolocation, for example, we have for world cover, we are using the SO2 grid in order to geolocate all the other sensors, and particularly Sentinel-1. It may be interesting also to know that somewhere.
Yeah, for the geolocation, for the connection between S2A, S2B, and between the bands, I have found the MPC level 1C quality report.
Good. If you can provide the link to.
Yeah, I put on the presentation that I'm preparing for the question, for the discussion.
Okay,
Yeah.
but drop the link to the report somewhere into the chat.
Okay.
So that the people can go directly to the source of information.
Okay.
Olivier, we can also put it on the website if you want somewhere.
Okay.
Yeah, by the agenda, perhaps, or.
Okay.
So. And as you said, we will make the PowerPoints in a PDF version available, linked to the agenda on the website, right?
Excellent.
Okay. So Aurélie and Martin, when done with the webinar, you can have the final version of your presentation, also in PDF version, if you want to provide it. Otherwise, I will put it in PDF to protect, and I will put it on the publish on the website. Okay?
Yeah.
Yeah, that'd be perfect. Oh, hang on. On my end, something. Yeah, that'll be perfect. We'll probably put something together and send it to you, but and that'll be this afternoon.
Okay.
Oui. Hello.
Yes. Hello.
Yes.
François.
Yes.
Nice to hear you.
Coffee break, right?
We were a little bit worried not hearing you.
No, because this was my coffee and you.
Good to hear you anyway.
So what should I do?
Nothing. Now you can shut down the mic and mute your mic and wait for Aurélie. She will introduce you in a moment.
You're worried for nothing, so.
It's all my life.
Hi, François. Good to see
Hello.
you here.
Okay. I'm just supposed to open my camera or not? Hello, Dano.
Hi, long time no see.
Yes.
I think last time was on the GARCIA pit.
Yes, it was. I think, well, 12 years ago, something like that.
Yeah, a long time ago.
I have some pictures. Okay. So, no video for me. Nice.
You can try on the bottom, share your video to activate. Oui.
Yes.
Irene or Sabrina, can you give François?
Yes, Sabrina is doing it.
Okay, good.
You can now try, François.
What do you want?
I think he was already.
Yes, I'm ready. You want I'm sticking if you want?
Yeah.
It's a nice project. And we're looking for more data.
More and more.
More money. And no more COVID. Je pense qu'on va être confiné, hein.
I think we certainly share that view, François.
Okay.
So both François and Kevin, they are just speaking, not sharing anything.
No.
Okay, so it's 11:30, and I think we should restart again. And just very quickly, who has joined us just now? I would like to enforce some rules. So all the attendees are muted. If they have questions to make, they should post those on the question and answer panel, which you can find in the tool. So write your questions to the speakers. And at the end of each session, there will be a 15-minute discussion session where all the most relevant and best questions will be answered by the speakers. We enforce also for the speakers always to keep the timetable. And so 12:15, you should be over with all your talks, just to have these 15 minutes of question and answer. Okay, so we can start. Aurélie, thank you.
Yeah, thank you. So I'm sharing my screen. Is that okay?
Yes, we can see it.
Okay.
Perfect.
Thank you. Thank you. What I would like to do is, so hi everyone. I'm glad to be there this morning on behalf of the Space for Shore Consortium for this, showing you this condensé of the main activities we've performed these last 2 years during the ESA Coastal Erosion project. And I would like to take the opportunity to thank ESA in the meanwhile for trusting us in this adventure and giving us the key and some kind of legitimacy also for moving outside France with regards to the coastal erosion issues and targeting European coastlines and maybe the international market soon. So, first, for those who don't know us, and I'm sure there are some in the room, IHE is quite a young company based in Bordeaux, in the southwest of France. We're a spin-off of Bordeaux University, and we're having 15, 20 years of background in satellite remote sensing applied to coastal areas. We are the leader of the Space for Shore team, gathering know-how in the use of both optical and SAR remote sensing for coastal monitoring all around the European coastlines in Greece, Romania, with Terra-Signa, Portugal, University of Aveiro, Germany, and France, of course. This team has been seconded and supported since early stages of the proposal by coastal erosion experts, namely, they know, typically knowing better than us and better than anyone, their coastal regions, pilot areas of the project, and namely these guys are from Aveiro University in Portugal, the University of Bucharest Marine Station, from French regions. There you have the pictures of François that will tell a word in a couple of 10 minutes, and also Germany. Today, François will be one of these representatives of the coastal scientific community, and he provided us with some others, Stéphane Costa also at University of Caen, really great support in the project and during the project. So finally, and at the end, the closure will be made, and we have the pleasure to host quite renowned international expert, Professor Dano ROELVINK, that to be honest, he has just discovered the project outcomes some days ago, and he will share with us his opinion
and feedback with regards to how Earth observation has been tackling coastal hazards issues and coastal erosion in particular. I'm moving next. So starting from the beginning, when we've discovered the willingness of ESA to support and boost the topic of coastal erosion from space, the first thing we thought about was, okay, and it has been, to be honest, the main driver, our main driver, all around the project, that was to consider all the European types of coastline and coastal geomorphology, as Martin and the other guys told us earlier. Of course, depending on this kind of wind wave forcing, considering the tidal range, and also the kind of sediments you can find around the coastlines. Our deep convictions all around this time that there's no universal single indicator to deal with the topic of coastal erosion around the world. But the necessity to tackle a range of coastal geomorphological indicators to be investigated and thus to be in line with what the scientists and the coastal managers are expecting from remote sensing, that is being the most closer possible to
how shoreline and coastal erosion is monitored in the field. Our second thought was, wow, how can we make the best use of Sentinel products and satellite archives having in general 10-20 meter resolution, and knowing that today we pretty much rely on very high resolution imagery to have accurate positioning of the shoreline from space, and for the monitoring of this coastal change the most accurate possible. Because what you all may know, depending on your knowledge about coastal erosion, is that scientists and people in charge of shoreline monitoring and planning are expecting products to be around 1 meter accuracy, and this is typically the case here over the picture, where the cliff, the top of the cliff line expected over the rocky areas is attended and expected to have 1 meter accuracy. And this is also the same over sandy beaches, coastal areas, where the dune foot, which is one of the major indicators to be investigated in the field and through remote sensing, is also expected from the end users to be located at around 1 meter accuracy. In some other regions where the tidal range is low, this is in microtidal areas like over the Mediterranean Sea, monitoring the position of the shoreline from 1 year to another is really much relevant using waterline, as has been shown by ARGANS around the Spanish coastline, because we can extract from sentinel imagery successive positions that can be arranged in finally one mean position of the main shoreline or the mean water level at some periods of the year, and also extract some other relevant indicators as the upper swash limit that is sometimes the indicator that is followed and surveyed over the beaches. Again, the accuracy required from the end users in France, but in many other places like in Greece and Romania, is of the order of 1-2 meter accuracy for this waterline or swash upper excursion limit as shoreline indicators. Over these microtidal coastal regions, there's also a huge interest, and ARGANS showed us some of their results about having also information about the underwater, and in particular about changes in shallow water bathymetry, the location of the initial sandbars, and their morphological change and migration over time. Tidal flats. You know that there are very large and low relief intertidal banks found in general in sheltered areas where the tide is high or sometimes very high, megatidal areas, like in Northern Europe. And there you have a picture of the Wadden Sea in Germany, which has always also been studied during the project. This location offers extraordinary coastal landscapes and, of course, home for amazing biodiversity, birds, marine life, seagrass meadows that are expanding the most over this kind of tidal areas. Finally, to take account with all these amazing coastal landscapes and specificities with regards to coastal erosion, we've selected a number of pilot areas in Europe, 8 to be exact, in 5 European countries: France, Germany, Portugal, Greece, and Romania, to be relevant for carrying the activities. A bit more than 2,000 kilometers were also monitored during the project, and information about coastal change over the 20 years period required by ESA was given for about 1,000 kilometers. You can see there the logos of the community of about 30 coastal managers, coastal cities, administrations at local, regional level, environmental authorities, institutions that have been engaged in the 5 countries. Some others joined more opportunistically, I would say, during the project, and all actively participated by providing first their requirements for the satellite products, the frequency, the accuracy they were asking, and they followed the project development during the 2 years, and they were delivered with the products last October, November, and some of them had some time to expertise and review these products and to share their feedback with us. One of these end-user members is Kevin Bergeron. He's a coastal manager, representative of CAVEM intercoastal community in the south of France, Frejus and Raphael cities, and he's present today, and he will give you his opinion and feedback with regards to how he could use in the near future these satellite products. Now, in the next slides, I propose to showcase the major outcomes of our activities and highlight our main coastal erosion satellite products. Some of them you will discover it with this one first, are very on the shelf, ready for market uptake, and others are more experimental but very promising. So here in front of you, you have a time series of 30 years of shoreline positions. Shoreline here being the Gin Foot over the coast of Nouvelle-Aquitaine in the southwest of France, and based on the archival spot and Sentinel-2 datasets. So these are 10 meters and 20 meters resolution data that has been used. So this area is a famous hotspot of coastal erosion in France, because here the coastal retreat in average is 5 meters per year. And the coast this last decade have been retreated by 300 meters in the last 50 years. So when comparing the Gin Foot extracting from this data set of 10, 20 meter resolution data with ground truth, the accuracy of this product was in a range of the order of 10 meter. That is more or less the pixel size of Spot 5 and Sentinel-2 imagery. What was relevant from the point of view of coastal managers and from the point of view of the Coastal Regional Observatory, Observatoire de la Côte Aquitaine, is the ability to get new dates, I would say, of historical shoreline positions back in the 80s and in the 90s, where there were no field surveys at the time, but only a couple of some orthophotos from which were derived old position of the shoreline. So this shoreline location over this area, this is about 30-40 kilometers area on this particular picture, has been reconstructed on a regular time frame of about 2 years in average. And even if the accuracy of each of these single lines is about 10 meters, the coast is retreating so fast that using this data set of Earth observation data appears to be relevant for long-time shoreline monitoring. I'm moving next to this additional picture to show you on top the change in shoreline position with the 2 extreme dates of the time series, and the mean coastal erosion rate you can find here as a legend in meter per year, that in general are well correlated with the background information we had, and we know from this area that is in average over this period in between 4 to 6 meters per year. So what has been done is also to make forecasts of shoreline position for the next decade at horizon 2030, 2040 by fitting statistical methods, models to the shoreline time series. So this kind of information, maybe you may know for those of you that are quite experts over this kind of topics, is quite classical in well-monitored coastal areas where a shoreline action plan has been set up, for instance. But in general, this is done at the local scale, 1-2 kilometers in front of the major stakes and the seafront in the coastal cities. Why? By using the archives of satellite data, it's quite easy to document large-scale shoreline change over tens or hundreds of kilometers. Okay, so now I propose to move over another area.
Some of you may know is the Normandy coastline, the coast of Cotentin. My intention with this slide is to show you how this data can also document short-time changes affecting the coastline during typically major storm events. So the area you have in front of you is on the west coast of Cotentin, and the linear length is about 30 kilometers. Last winter, 1 year ago, you can see here the dates, the area has been exposed to 2 successive storms, Sarah and Eleanor, and the coastline retreated severely by tens of meters, 10 meters in average, 8 to be exact, and in some areas, some very local areas, changes that have been held to almost 80 meters from successive storm events in a couple of months. So using Sentinel-2, this is what has been done, and you have the picture in front of you. Here, the general accuracy deriving June foot from Sentinel-2 in average was of the order of 5 meters. And the diagnostic of large-scale shoreline retreat has been done. And also, it has allowed, in the meanwhile, additionally, to monitor and to assess the recovery of the upper beach and the coastal dunes in the following spring to 2020, with sand accumulating a bit in the following months at springtime. This classical phenomenon of beach recovery is very natural, but what is interesting with this information is that using Sentinel-2 datasets opens the double perspective of monitoring both long-term and short-term changes, both in the retreat of the coastline and the propagation, the migration seaward of the coastline, thus opening the door for the assessment of the impact of extreme storm events and long-term trends, and in the meanwhile, both at local and regional scales. And to our mind, there's not much other technology that can do so, that is focusing on all possible space and time scales which are relevant for coastal dynamics. And this is more or less the words that were used by Professor Stephen Costa from Caen University, the regional coastal expert in this area. And during the last demonstration meetings in Normandy last November. Along the beaches, the coastal community has also expressed much interest in knowing better the nearshore, as we were telling you, ARGANS and I, nearshore bathymetry, and also the subtidal beach morphodynamics. And this has been done studying sandbar dynamics through Sentinel-2 time series. And there you can find some kind of illustration that ARGANS have shown you over other areas, where on the right you have the time series of sandbar position over this picture, this coastal area. And there you can monitor the variation in the position and morphology of the sandbars. Has been done, for instance, for using video cameras on a weekly, monthly basis thanks to Sentinel updating capability and a revisit. And this information can be summarized in this kind of graphics in the center position of the slide, where the position along the shore is in x-axis and time over y. And the color indicates the coastal migration of the sandbars, with warm color in red, with the sandbars coming closer to the beach, and typically in summer, and the blue dark when it goes offshore. This is typically when the sandbars are locating during winter due to the effects of storm-induced currents. So this is another very interesting application on how Sentinel-2 data can be used in routine to assess beach and shoreline vulnerability to storms, taking into account the degree of natural protection offered by the underwater sandbars, which is known by the community of crucial importance in case of major storms. So this product has been demonstrated in several places along the European coastlines, in France, in Romania also, pretty much, and to a limited extent in Germany also. We're leaving the high-energy Atlantic coast for the Mediterranean region, where another kind of shoreline has been investigated. ARGANS told pretty much about it, so I will be quick. Over these microtidal regions, the shoreline is commonly defined by the waterline, and the type of surveyed waterline in the field may differ from one region to another, from one surveyor to another. Here, what we're showing is the possibility to monitor every type of waterline through the time series on Sentinel dataset, and by extracting successive waterlines through a defined period of time, and then a reading pen, for instance, to get the mean waterline, and getting, where this is relevant, other indicators that the upper maximum extent of the swash zone excursion. And this is typically this kind of information and indicators that is followed in the field over the French Mediterranean area. I will let, in a minute, François share his feedback about that. So this has been done again in France, Greece, and Romania, all European Mediterranean pilot areas, and it allows very accurate results of the mean waterline position or maximum extent of the swash, and in average, in best cases, the planimetric accuracy was of the order of 2 meters, when, for instance, there we are in Frejus, Saint-Raphael Bay, south of France, where the use of about 9-10 Sentinel-2 images over 2 months and a half, gives this 2-meter accuracy. And just to be exhaustive, this mean waterline has been compared with simultaneous ground truths acquired by Kevin Bergeron, which we will talk in a minute also. Next is an example of how this is possible in the particular favorable environmental conditions to get also very frequent satellite derived bathymetry in the near shore. So this is next slide. Yeah. So we're now again in the same area. This is Saint-Raphael. And Kevin has been acquiring this kind of bathymetric surveys from the field in between the last decades for 4 or 5 years, I guess. And what is shown is that we demonstrated once again that satellite derived bathymetry is really a valuable and powerful tool to provide seasonal estimations of the change in bottom elevation and the change in geomorphological patterns like the location and the sandbars and their morphology. And then this sequence of satellite derived bathymetry from 2015 to 2020 show us that by extension, this is possible to monitor also the change in the bathymetry and thus
the way sediment stocks are fluctuating over time at both the seasonal scale and yearly scale. So all these results gives evidence on trends in using Earth observations and sentinel visions from our point of view to feed in routine operational monitoring systems and infrastructures. And now I would like to leave the floor to our colleagues, François and Kevin. If everything is going well, they should be able to tell some words about what they think about all of this. So I guess you can now activate your micro. François first.
Yes, okay, hello. Well, the thing is that there is two points. The first is connected to the shoreline position. What did I see is very interesting because they managed to localize the shoreline position as we do on the field when we use DGPS. So that means that we can combine several data from satellite images and data from the field. And it was a large challenge to define the shoreline position. Aurélie told you that I always say that the frequency is very interesting because it's possible to have the shoreline position every 2 weeks and so on. But more or less it's, how can I say, a little bit common because I think that the more important point is the bathymetry. It's new to define the bathymetry with image satellite like this and seems to be accurate. Perhaps Aurélie can give you some information. But you saw in the pictures that for this example, because it is clear water, I'm okay. It is clear water, it is Mediterranean Sea, and during the images there is no cloud and there is no wave. Okay, but with this methodology, it's possible to have a lot of bathymetry and to compare them, which is nice, new, and probably not so expensive than if you need to take a boat and if you do some sounding points. So it's a very promising, and I think that a lot of people, a lot of not only researchers would be interested in that. I can continue if you want, but I think I summarize. Kevin?
No.
Yes, Kevin, maybe you can think, yeah.
Yes, we can.
The following.
Hear Kevin?
Can you hear me?
Yes, yes.
Yes. So, good morning everyone, and thank you to allow me to say a few words in my testimony. My point of view in one of my missions in my area with this job. I've been monitoring the coastline since 2011, 4 times a year with GPS. It's one of my priority in Natura 2000 in my local area. When I began this monitoring, it was to have a vision of the natural evolution of the coastline, especially on the sandy beaches. Now we must think about solution to the retreat of the coastline that we can start for 3 years now. We must find a strategy and then planning for the future in case of environmental, economic and social issues. As a consequence, with the reality, we have a major problem of submersion and erosion of the coastline because of marine storms and in our agglomeration, CAVEM. The objective was to have decision support tools for elected officials people. Now, the study and work made it possible to obtain precise idea of the masses of submarine sands, bathymetry change and evolution, and the evolution of the coastline, balance accretion and erosion. With these all cartographic elements, they can anticipate climatic changement and define some action, for example, territorial recomposition, in the direction of natural evolution that we constate and will accelerate in the future. In addition, very interesting also because we see the areas with a sediment block to reload the eroded sandy beaches. We know roughly the priority areas to work. In addition, the most interesting for us here is to able present maps. I asked to IC, have color red for erosion and green to accretion, so thank you. It's very effective at communicating to people and showing the territory and the evolution of the territory in positive and negative issues. This gives an overview of the movement, the vulnerable areas, protected areas. This study confirms field data with precision. It's very acceptable for us. Thank you.
Yeah.
If I can add yes, we have time just to add one point. Because before we go there for closure, and if you can show us the picture, because we don't show the picture right now, we just see the agenda, which is interesting, but the coffee break.
Why that?
I think we just see the agenda, not the picture.
Because the share option is active. Okay, thank you. I was not the presenter anymore. Okay, I'm moving back to the slides. Yes.
Okay, well, so what I would like to say is that the depth is around 5, 6, or 7 meters, which is very interesting because more or less it is close to the depth of closure. And like this, sediment budget can be computed and calculated. And you see in this picture that during the winter, of course, but we have to show that during the winter there is more erosion. Even if in the medium term, we can see on the picture, on the bottom on the right, that the sediment budget is more or less stable. So thank you for this data.
Exactly. So both seasonal scale and long-term dynamics providing different kind of results and knowledge, finally.
Exactly.
Excellent. Moving forward, thank you, the two of us. So after speaking so long about sandy beaches and sandy shorelines, I would like also to share and take the opportunity to share some information and some of the results, more experimental, we get over the rocky areas. So where the main issue about coastal erosion is being able to catch subtle annual changes in the cliffs, while most of them are undergoing low to very low erosion rates of the order of 10 or 20 centimeters per year. So there are different processing strategies have been employed over the rocky areas to get these cliff lines requested by the end users and the scientific community, and in particular, the cliff apex, this line, if my mouse is coming, to be extracted from the satellite imagery. From both spots, Sentinel-2, and this has been also from Pleiad, but this is not shown today. Also, DEHOUCK reconstructions using pairs of very high resolution data like Pleiad and also Sentinel-1 radar data have been investigated, and I will show you a result in the next slide. Unfortunately, none of them strategies and none of them applied to the decametric products, Spot, Sentinel-2, and so on, were really efficient and accurate enough to extract the top of the cliff lines over the time. But really interesting patterns arise from the analysis of the time series of Sentinel-2 derived cliff apex. And this is the picture you have in front of you over the area. So there we are in Normandy. We found on some of the major coastal retreats
observed there in red from a short time series of 3-4 years of Sentinel-2 data was really well correlated with major rocky falls over the area. And there you have the pictures taken by Stefan Costa over the same periods that is giving evidence of the capability, expected capability of analyzing long time series of Sentinel-2 for extracting automatically this kind of coastal landslides. So these preliminary results, even if each Sentinel-2 cliff apex line is 10-meter accuracy, so not sufficient for the monitoring exactly the coastal erosion rate. However, there's the possibility of using the Sentinel-2 time series for feeding a kind of routine monitoring system and
probably contributing to raising the awareness of coastal managers by pointing out the most vulnerable areas thanks to these historical observations. So this is what pointed out Stefan Costa during the demo meetings, that there were probably room for feeding knowledge and the scientific community first with this kind of promising products. BHAMs have also been reconstructed in some areas, in rocky areas. Here we're not any longer in Normandy, but around the Pays Basque in the southwest of France. And you have an example of how Pléiade data, very high resolution, allow the detection of coastal landslides, so there, and are useful for providing an estimation, I'm looking for the mouse, of the evaluation of the volume of material lost from the cliffs and that are fallen on the beaches. At the end, star interferometry using Sentinel-1 time series
has also been experimented, and it gives some promising, very first interesting results, which need to be at this stage more thoroughly examined. They show coastal subsidence in red over this picture, occurring landward of the cliff front. There you have some kind of variations that has been monitored to be of the order over 4 years of about 8 to 10 centimeters. And this has been correlated with past events of coastal landslides. So the three more experimental and less mature, to be honest, products that are focusing on rocky coastal areas, otherwise open very promising activities to be continued with the final end users. These results, first a set of perspectives and conclusions. These results, they convince us that Earth's observation data, but not only us, but also the end users and the scientific community, can provide added value products for coastal erosion monitoring. It's not that new, but this is a reality. Beach and shoreline planning also. They provide affordable, easy to update, flexible, and multi-scale products for shoreline and coastal erosion monitoring. So next step for us is to move from the standard products towards more customized services that will serve really operational issues. And there you have 3 examples of how these products could feed and provide support to beach nourishment operations by the assessment, for instance, of pre-storm vulnerability of the beaches and the shoreline. Then, a more integrated also service could be expected over the rocky areas, with maybe the ability to have some kind of anticipation of coastal landslides. And last but not the least, ARGANS showed us some examples of some used and interesting land use, land cover products over coastal areas. Coastal conservation is, of course, another topic of growing relevance in the context of climate change and the conservation of coastal biodiversity with regards to coastal hazards also. So the three very concrete issues as driven, of course, as we've seen, by local responsibilities and duties of coastal manager in monitoring the coastal areas and shoreline planning, but it goes also well beyond the local scale by addressing global challenges. The first of them is the adaptation to climate change, and as we mentioned, the conservation of some kind of exceptional coastal landscapes all over the world, and biodiversity reservoirs. Like over there, you have a picture from French Guiana about mangrove facing coastal erosion issues. And we are really grateful to the CNES, the French space agencies, to the coastal and
users in French Guiana, the Coastal Regional Observatory, and the Prefecture, Région Guyane, for giving us the opportunity to, let's say, tropicalize our space foreshore offer of services through the Copernicus Innovation Challenge that has been awarded to us some months ago by the end of 2020. And now I would like to leave the floor to Dano ROELVINK. He will share some word with you about how he feels about all the benefits of using Earth observation data in his past activities. There you have some information, maybe some graphics you may know about the work that has been undertaken by scientists, community using time series of Landsat data, monitoring the shoreline. Dano will share with you how these Earth observation products will now be able to document all these areas over the world where coastal erosion rate and change is not well known. Please, Dano, if you want the micro, this is
okay. Okay, thank you very much. We'll continue with your presentation, or shall I share?
You can share. You can share
okay.
your presentation
I will.
if you prefer.
Yes. Okay.
Please remember to keep the time, so quite quickly. Okay,
yeah.
Thank you.
Okay, so yeah, my main conclusions are that it's a very interesting further development of techniques that people have been working on for several years. But what strikes me particularly is a very good analysis of the accuracy of these methods, and also that this accuracy can be quite acceptable for many applications. There's a range of useful data set that has come out now for calibration or validation of, for instance, morphological models, coastline models, and depth averaged coastal area models. The applications I've seen in these presentations and in the information I could find is so far it's mostly more supervised applications. Question is, how robust are these methods in ungauged areas? The products from this project seem to be data sets produced for specific locations, quite a few specific locations, but nevertheless, and for certain coastal indices. And I'm hoping that we'll be able to obtain new algorithms and methods from it as a scientific community. I think the project has mainly been, let's say, in the phase of proofs of concept. So possible applications could be, for instance, the analysis of coastal changes and calibration of models on a decadal scale. Here's an example from Senegal of something we did recently, where you see on the right the observations from Landsat and Sentinel, and on the left, well, this is all Landsat actually, and on the left, a coastline model that is replicating this. the goal would be for the future to work on data assimilation and automatic calibration. Question is really, can we do it anywhere in the world? Methods, not just not just finished products will be available to the coastal community, and preferably it would be very nice if these methods can be made available in the cloud, e.g. as in Google Earth Engine, so there's no need to download these massive images, but only end products. An example of how these how the results of this project could be made available is like scientific papers, open source algorithms, and finished data sets in a website, something like in the ResKit project that you can visit here. That would be very, very convenient for the coastal community. And the outlook, my dream, let's say, is that we would have a number of operational systems where data can be extracted on the fly. And there's some early examples now, Deltares, Aqua Monitor, Shoreline Monitor. There are more of those. Perhaps they could be similar systems hosted by ESA. They would need to be easily accessible and allowing a continuous feedback based on local validation. On the right, I show a picture of, let's say, cleaned up data based on the Shoreline Monitor, but I can tell you the original picture looked a lot worse. So really local validation, even just with common sense, makes these data sets a lot more reliable. Would be great if we could collaborate with national, regional organizations and research institutes worldwide and invite citizen scientists. And that's it for me.
More or less in time, Dano. So yes, good. Maybe you can go to the next slide.
Yes. Really, we don't hear you.
I'm coming up. Just to show you where you can get the information from the Space Social project. I'm going to this next slide and last slide. We thank you all for your attention. For sure, do not hesitate to contact us. You have here our address, and you will find on the Space Force website, there you have the link, all the information and previous presentations made during the demo meetings in the several European regions. You can find it publicly open there. And you have also some contacts about our partners of the Space Social community in the several countries that participated in these activities. Thank you. I'm finished.
Okay.
So
there's some.
You did faster than planned, Aurélie.
And also sharp on time, ARINO, Olivier.
It's not ironic.
It is perfect. We have more time to close the project, and the people can already prepare the aperitif. Is any further question on the presentation of Aurélie?
Yeah, there was two main questions. I started to give an answer to at least one. One was about results and products based on SAR data. I think it was for the beginning of the presentation. Water lines, upper source limit, and bathymetry. Yes, we did. We did some massive productions and tests in many at many sites, many locations. What happened is that For bathymetry, for instance, accuracy is about 2 meters. So it's based on a totally different approach, wave crests and wave deformation approaching the coast. So with such accuracy, it is interesting for sediment movements and sediment banks, sedimentation along the coast and near harbor entrance, for instance. But it's not as accurate as what we can do with optical data, where we can reach very high precision, almost like LiDAR. In the best case, when the water is very clear, we can reach 25 centimeters of accuracy, and on average it's around 50 centimeters, what showed ARGANS as well. About projection, we showed projection of dune foot. Yes, you're right, Ruth. Projection, well, in the case we presented was on a particular location, a city, where some places are defended by walls and some other are not. So projections are made everywhere, and it is important because planners and for planning, it is needed to know if a wall, a particular wall, is of high importance, if we need to maintain a wall in a place where erosion is fast or not, and what is the cost associated to this defense wall if we maintain it. Indeed, when calculating long-term erosion trends, we need to take into account protection measures. It can be worse, but very often it's beach nourishment that we have also to take into account to not to underestimate the erosion trends. And it is something that has been underlined by the coastal experts that were involved in the project. I think it was the two main questions I saw during when Aurélie was talking. I don't know if there is any other one. Ah, yes, new one. Can you project coastline erosion as a function of sea level rise? Wow, it is the question, yes. The main one. It is something that should be done. I think we have to associate it more data. Maybe Dano would be more easy than me to answer this question and to address this very important issue. We need more data than the ones maybe retrieved from direct Earth observation. We need also DEM, coastal DEM, and more data and make a data fusion. But I'm pretty sure that what was derived in terms of erosion trends would be really important to inject in some models to project coastline at a large scale, worldwide scale, I would hope, and also to have long-term projections. Yes. Aurélie, maybe you would like to.
Could I comment on this, or?
Yeah.
Well, of course, you could use simple methods like the Bruin rule if you have a coastal slope, which could be hopefully derived from the data available here. But then that's only a very first approximation, and additional modeling, for instance, using coastline modeling that includes sources and sinks related to tidal inlets, for instance, I could refine this result a lot. So projections can be made, and this is a very good start of the data, but just of course, extrapolating the current trends will not arrive at the requested answer.
Yeah, thanks. a new question about how to process Sentinel for bathymetry. Is it about Sentinel-2 and Sentinel-1 or Sentinel-1 only? Sentinel-2, well, it's all about water transparency. Maybe you understood that. And Sentinel-1, well, water transparency doesn't work anymore for sure. And here we use the wave crest position, and we derive from the wave crest deformation along the coast. We derive the water depth. Not that easy, not an easy task, but it works, and it works with Sentinel-2 as well. Well, so optical and radar data are possible sensors for that.
So, Aurélie, Virginie, you have still 4 minutes to run. If you have any other questions, suggestions, otherwise I will take the floor.
Yeah, you can. Again, thank you very much for these 2 lectures. It was a great experience. And I hope we have again following activities over these topics and others.
In a way or in another. So thank you very much for keeping the time. And to you and the other consortium, it was a perfect timing. We will put the presentation on the site. So you check the site, the website will put the presentation. Thanks to therefore to Virginie, Aurélie, Sylvain and their users for this nice presentation. Thanks to Martin, Andres, Anne-Laure and their users also for this real clear presentation during the webinar. I noted that we had quite a stable participation of 140 participants clearly logged on the video conference. Meanwhile, my colleague Fabrizio is loading some response to the question and answer, etc. I would like to highlight the fact that the European Space Agency is a research and development agency. Therefore, we can and aim at demonstrate the usefulness of satellite data. But unfortunately, as you know, we are not a paid agency. We are not a bank, and we are not an operational agency. I engage all the users, but also all the project managers to lobby their national delegation to see how this can be transited to a more operational environment, which is maybe we can support part of it, and we will have several look to extend the project, like Yves-Louis mentioned earlier this morning. But don't think that we can support the operation. Okay. Nevertheless, we are here. We will conclude that meeting today, and I would like to have the page loaded from Fabrizio to see the question and answer and have some more elements. Fabrizio or Sabrina? Or
yes,
Fabrizio.
Yes.
Yeah,
going
okay.
to share. Yeah. Okay, I highlighted in red the most relevant question because the other are already being answered. Apart from the last one, this that came at the end of the presentation, this one. So for the discussion, so Olivier.
Okay, so about the co-registration, I think we get enough reply, and we pass you the link to our quality control documents. What are the one in red, Fabrizio? So the application that we develop, of course, is open to the general scientific and technical community, but it's through the publication, through the consortium, that you may find a way to have it in operation and tailored for your specific application. We demonstrate, we eventually support publication of the results. We provide all the information, but we are not value-added company. There are plenty of value-added company available in the different member states that can deal with the specificity of your requirement. Okay, are the obtained results public available through our system, to your system? All the results of these two projects, the public part will be available through our Sentinel for EO4Society website, definitively, and we'll give the website address if Fabrizio, you can load it. Any other? Okay, the bullet. Do you have any specific regarding Sentinel-2 and MNO2? This is outside of this webinar question, but it has been shown by Yves-Louis that some of the emission by ship can be monitored, and specifically with the 5P satellite, because the ship emit a quite intense gas. Do you have any recommendation in terms of instrument-specific resolution?
Yeah, this is for the two consortia, that if they have some recommendation in terms of resolution, coverage, revisit time for the coming Asian mission.
Okay, at the moment I can say that we are working on the at ESA, some of our colleagues, more specifically from ESTEC, are working on the Sentinel 1, but Sentinel 2 and Sentinel 3 new generation, meaning the continuity after the first one, and they are defining that. And basically, from my understanding of the two-day meeting, what was appealing is that the revisit time is one of the most important stuff at the 10-meter resolution, or eventually slightly better. Of course, we hear, and from the last presentation specifically, a lot of players can be and will be used. And it's normal. The higher the resolution, the better product you will have at the end. But making an assumption in between the resolution and the revisiting is something different. When you want to keep a consequent revisit, frequent revisit of 5 days, like it is with a Sentinel, we may have the capacity to increase slightly the resolution, but I doubt that it will be at 1 meter resolution. It will be at a couple of meter or 5 meter, but it will very strongly depend on the requirement and on the push from the users. So you provided, Fabrizio, several links, and we'll put on the coastal erosion webinar all the presentation. And the two consortium websites are available, and this is for business and private, and more deep interaction for each of the two projects. Do you have anything else to add, Fabrizio?
No, not on my side. I don't know if somebody from the two consortia would like to add something. I don't know. We have 20 minutes, more or less.
Aurélie, Simon?
Please, if I may, Olivier, Fabrizio. I'd just like to thank Olivier and Fabrizio for the support they've given us throughout the project. Quite often they're the unsung heroes that nobody hears about. So thank you very much indeed to both of you. I think it's also been an excellent platform for us to showcase what we've done, both ourselves and IC. And I think what we have shown and what we have proven is that the national investment in the Sentinel missions has been an extremely good investment. This webinar has given us lots of things to think about, lots of things that we'd like to expand and move forward on. And I think it's been, the last 2 years has been a phenomenally enjoyable project to work on. And I'd like to very much publicly thank the community, the consortium that I've been working in. It's been a very, very exciting time for me, and it's been a very interesting project. So ESA, thank you very much.
Thank you to you, Martin. Already, you're smiling.
Can I follow up from Martin? This is Andres from BGILS, the British Geological Survey. And I will reinforce what Martin has said, the thanks to ESA and all the support. But I would like to probably tell you what my take-home message is, that many of the products, the waterlines and shorelines, for me, they are already operational. So they are things that are ready to be used. So it's an archive, but we are planning to get a lot of useful information. It's not a proof of concept. It's a very useful information that we are already using and has the quality that the end users requires. And yes, of course, there are other products that are still as proof of concept that will need a bit more development. But I just want to make clear that the shorelines, and in particular the waterlines, are already being operational. That's my point.
So I do agree with you, Andres, and please pass a message to the regional environmental agencies, the geological agencies of your national country. Pass the message also at one point in time to the European Commission that may support some of the services through the Copernicus services. I'm not sure that they are doing anything on coastal erosion, but they do a lot on the cement, for example, and you may call them and investigate with them. It would be another idea. So I think it's time to close. Aurélie, do you want to say something?
No, it's perfectly true, and we perfectly are in line with all that has been said, the guys. Yeah.
Okay, so it was a pleasure to work with all of you, and I will like to close the meeting now. We keep in touch, and we finish the latest with a minute of the different meeting. But congratulations, we get a very stable participation of 140 persons permanently listening to what you were saying and and the achievement of the project. I'm satisfied on another point of view and waiting for the latest deliverable to arrive before signing for the payment. Thank you very much. Have a nice afternoon. Bye-bye.
Thank you.
Bye-bye. Well done, Aurélie.
Thank you, Olivier. Thank you all.
Bye-bye. Thank you, Lars.
Thank you.
Bye-bye.
Bye.
Bye, all.
Thank you.
And Sabrina. Ciao.
Ciao, Olivier. Ciao. Fabrizio. Ciao.
Bye, thanks.
Ciao.
Thank you.
Ciao, Aurélie. Ciao, Aurélie.
Bye, everybody.
Thank you, everybody, for joining.
So, are you happy?
Yeah.
I think it was really, really